to Port Manatee was subject to a spike in nutrient concentrations, particularly nitrogen and phosphorus. And that spike corresponded to an increase in phytoplankton abundance or a phytoplankton bloom. But our initial field sampling efforts and data acquired from remote sensing platforms confirmed that the concentrations of chlorophyll, which is a proxy for phytoplankton abundance, were fairly localized and short-lived. So as we continue to sample the waters, not only in the immediate vicinity of Port Manatee in southern Tampa Bay, but in other reference areas, I think what we're seeing that there continues to be a dilution, a decline in some of those important chemical constituents. And the values that we're seeing today are much more typical of what we see in the historical record. So I think with that said, I'm going to give an opportunity, folks on my team, to go ahead and answer any questions that you might have. So it might be easier if I direct the questions to them.
Is it fair to say that we may have dodged a bullet?
Yeah, again, I think that, the agency that was responsible in large part for responding had to do so with a number of priorities, right? There's obviously the priority to protect human health, right? But also to protect the environment. And I think the decision that they made was a good one in the sense, right, that the event appeared to be fairly short-lived with no serious acute impacts.
Is there any correlation between the increase in nutrients to the red tide that we're now seeing in that area? Even though the red tide is reportedly not that severe, but is there any correlation occurring?
Yeah, I mean, again, so it's hard to put together a cause and effect relationship there. Again, what we see now in the Bay is a decline in the nutrient concentrations relative to the initial pulse that in Port Manatee. There are low to background concentrations of red tide organism in the southern part of the Bay right now, but I think it would be premature to draw a cause and effect relationship between those two things.
What about the release of heavy metals within that water and the impact on the seagrass beds in the area? Can you talk about that, what you've seen so far, and what the concern is more long term?
Yeah, so I think there's two parts to that. One is, has there been an impact of heavy metals in the system? And I'm going to let Kristen Buck, Dr. Kristen Buck, our chemical oceanographer, speak to that. And the other part of that is whether or not there's a longer term impact on seagrasses, which we all know harbor a large number of ecologically and economically important species. So I'll first let Kristen come and talk about the trace metals.
Yeah, thanks. That's a great question. So it's something we're looking at. We collected samples from the water column and from the sediments. And I think it was pointed out we've had several sampling efforts over time. Those samples take, months to analyze. So it'll be a while before we actually get the metal data back. But we will be looking for those, for heavy metals in the water, so dissolved, but also in the particulate phase and in the sediments.
From an observational standpoint, have you noticed any decline in the seagrass area or any diminishment in those important areas?
I wouldn't know. So, that's really being looked at by other groups. So FWC, DEP, and some of those people. But we were not actively monitoring seagrass, leading up to this or during the event.
What can the heavy metals do to the environment if you find something?
Yeah, so it really depends on the metal. So some metals act more like nutrients than they do as toxicants. And metals in general, their impact on the environment, I think of it as like a Goldilocks curve. So, you have a range that's just right, and that can be a pretty wide concentration range. So you can have a lot of variability, and it has no negative impact or isn't a limiting nutrient. When you start heading off into the too high or too low, that's when metals become really important for an ecosystem. It's hard to say. So it will depend on the element, and I think you would until we have more data, I don't know that we know yet.
Have we found what kind of metal we are looking at?
Oh yeah, so at least in my lab, we'll be looking at the trace metals that are the most bioactive typically for phytoplankton. So copper, lead, manganese, zinc, cadmium, iron, nickel, and cobalt.
And if those levels are higher, what does that do to the environment? What does that mean to us?
Yeah, so it can mean nothing at all. So you can have higher concentrations of these metals and not have a negative impact. We will be looking at them in the context of water quality guidelines, so we'll be able to give some feedback on whether we exceeded those water quality thresholds for any of those elements. Some of them can be toxic. That toxicity usually is manifested on the phytoplankton first because they're the smallest part of the ecosystem, so you'd expect to see it there. I'd also point out that in addition to measuring water and sediments, Steve Moralski's group is also collecting fish, and they'll be looking at metals there too.
Can I ask you about that, the fish and some of the other larger wildlife
Yep.
in the area? Have you seen any impact on those?
Oh, I'm sorry.
I'll get to it.
Circle back to
Yeah, we'll get to fish in just a sec if that's all right, because I wanted to make sure that I followed up on the seagrass question, right? And so one of the things that we were particularly interested in here in the college is looking at the transport and the transformation, ultimately the fate of the chemical constituents in the discharge water. I mean, I think people have recognized for a long time that if you have an increase in algal blooms, whether it's phytoplankton in the water column or macroalgae on the bottom, that there's a potential to negatively impact that important seagrass habitat. And one of the reasons that I mentioned are, cooperating entities or agencies or other groups that are involved in the sampling, like the Tampa Bay Estuary Program or the FWRI, is they regularly sample that seagrass habitat and are in a much better position to tell us whether or not it's been declined in response to the event. So, but with regard to fish, go ahead, Steve.
So in terms of fish, an obvious question that people have is seafood safety, right? So, what is the potential impact of eating fish in that vicinity? And the responsible authority is the State Department of Public Health. They've issued no warnings or in terms of consumption in that area that I'm aware of. We've taken fish samples there twice, once during the spill and once right after the spill. We're in the process of looking at potential contaminants that might be there. I can tell you that grossly looking at the fish that we caught there, and the fish were relatively abundant off of Port Manatee, they didn't show any obvious external signs like skin lesions and other things, but it'll remain to be seen, what the levels are in the fish flesh that we're analyzing.
And then what talk about levels of what?
So we're interested in, as Dr. Buck said, we're interested in metals. We're interested in high concentrations of nutrients that might be coming from that. We're also interested in radiologicals, so we'll be taking a look at all of that.
Can you talk about the timing of this event as it relates to the spawning of fish, because it's such an important breeding ground?
Yeah, that's a really good point. And if you look at what we call the big three, so they're speckled trout, redfish, and snook, their spawning seasons did not occur in overlapping. So that was actually, in terms of dodging a bullet, that was a good one. Other animals do spawn during that period of time, and so it's not, completely off the hook kind of thing. So, but still, the big three, would have spawning seasons later in the year.
How important will it be to continue to watch over the next coming weeks and months to see if there will be?
Well, sometimes you get residual effects, where you have a reservoir and it takes time to work its way through the system. And certainly in terms of pollutants of fish and shellfish, it takes a while for them to work their way through so we can actually identify potential issues. So we shouldn't be walking away from this yet. We need to keep some vigilance and monitoring.
You keep referencing different concentrations of metals. Which metals do you think would be the most concerning to wildlife?
Well, for wildlife, things like lead and arsenic and cadmium, to a certain extent copper, although copper is a vital element as well. And so we don't have a detailed concentration of what was in the reservoir, but so we're trying to interpret that from the samples that we're taking from the field.
Have we so far learned anything about the Bay that we didn't previously know, or what do you walk away from this situation thinking we need to change moving forward?
I mean, Zach, that's a good question as well. I think there, as I said before, there are a large number of entities that have been sampling Tampa Bay for a really long time. And I think what we learned here is that we need to better understand how the ecosystem of the Bay responds to a pulsed event like this, right? Because it affects the speciation of the chemicals that are involved, how those chemicals might be incorporated not only into the algal community but into the other biota as well. So it's that science really that helps us better understand, again, those biogeochemical processes that will enable us to better inform future sampling efforts, and I think that'll be a benefit to all involved. Yeah.
What needs to happen for that to kind of get down on the ground here? Is that a matter of funding, of interagency coordination? What are you talking about getting kind of involved in?
Yeah, I think all of the above, right? And so what, having recently come from the background in the state, right? I think what you're seeing is a concerted effort to put a greater investment, into environmental sampling, more comprehensive water quality monitoring. And that's good. But of course, it will always take coordination. I think, as I said before, this is just not a one pony show, right? There are a number of natural resource management agencies involved. We're fortunate to have the FWRI right here in our backyard, but the FWP, DOH, and other groups as well. And as I said before, I'm really, really grateful to folks like the Tampa Bay Estuary Program and all of their partners that are continually sampling in the Bay, so we have a good historical record and essentially reference data in order to evaluate future events. But I think we're on the right track, Zach.
Could someone explain those two maps at the bottom? They're 6 weeks apart and what they're showing in simple terms, I guess.
Yeah, I'm glad you asked that because our very competent physical oceanographer, Bob Weisberg, can do that.
Well, that was an interesting cue. No, that's a great question. So when the spill started, we implemented a tracer model which shows where the stuff goes. And so the one on the your lower left, is the concentration of what was coming out of Piney Point on April 6th, or maybe it was 8th, I forgot. Anyway, you can see the nice dark red, yellow colors where the concentration was highest. And this is where we had visual evidence of phytoplankton bloom. So the tracer actually did follow faithfully where the stuff went out of Piney Point. The one on the right-hand side is what the distribution looks like on May 20th, so a month and a half later. And the change in the coloration is the dilution that the tracer underwent. So whereas initially it was fairly high concentration near Piney Point and it hadn't really reached too far into the bay or into the Gulf of Mexico, you can see it all over the place in May 20th, but at concentrations reduced at least by a factor of 1,000. So even though it looks like it's all over, which it is, the concentrations are greatly reduced simply by dilution and also by consumption by the biota. So it's just a way of visualizing where the stuff went that came out of Piney Point and how it diluted over time.
Speaking of the dilution, when we first started research, there was a concern about not being frontal boundary pushing through to gain consistent winds and pushing out. How did last week's strong easterly winds and consistent winds help disperse it?
That's a great question. And actually it bears upon several of the other questions asked earlier. For about the first month of this spill, we had atypical southerly winds. And normally we get southerlies and it changes to northerly and switches all over the place. But since we had protracted southerly winds, the red tide that had been down by Charlotte Harbor actually systematically made its way up here. And so what we saw at the mouth of the bay, and what we're still seeing now, is actually organisms that came from the south, and they're kind of living here now, but it's not really due to anything that came out of Piney Point. And so we've had strong easterly winds all of this week, and that's helping to push the stuff out of the bay, and it's helping to flush the bay. You've had your hand up forever, so I'm going to...
So with red tide organisms creeping up north, with the concentrations that you guys are seeing now, is there the potential for future feeding of algae in the area, potentially perhaps kind of from the concentrations you guys see now in the area?
Sure. So as Dean Fraser already said, the concentrations are now kind of back to background levels. So there's no great concern that we're going to have an overabundance of growth of any phytoplankton. It's growing at background levels. The time of year when we really have to be concerned about red tide is in the early fall, late summer, early fall months. And it's a little too early now to prognosticate about what's going to happen then, although it's something that my group keeps an eye on, and we interact with our colleagues at FWC who actually go out and make samples of the organism offshore, and then we link that to our ocean circulation models to predict when it may come in. There's one more element to this, and that is what's happening in the deep Gulf of Mexico, what the Gulf of Mexico loop current is doing. And if you call me in about a month, I will make some prognostication about what I think might happen in the fall. Thank you. That's not my area, so I'll defer to my colleagues.
What was the question about? Consumption?
Yeah, just to make sure. So you're asking about the assimilation or consumption of nutrients by biota, right?
What's going on inside of the water, like in the microscopic? Can you explain that?
Yeah, I'm going to let Dr. Buck speak to that.
Sure. So, phytoplankton, base of the food web, they need light and they need nutrients to grow. And so the nutrients that are in the water are what drive phytoplankton growth. That's why, we see these correlations between phytoplankton as measured by chlorophyll and nutrient concentrations, associated with this event. Related to the red tide, I would point out that nutrient chemistry is complex. So there's a lot of different chemical forms of nitrogen and phosphorus, and we're still waiting for some of that data to come back to get a kind of really complete picture of what's happening. I'd also point out we're not alone, right? DEP, Tampa Bay Estuary Program, Hillsborough County, Pinellas County, Manatee, everybody's got water quality going on out there and are measuring nutrients. So I expect you'll continue to see a lot of data showing up on that dashboard. But that's really what we're talking about, is that nutrients are the food that phytoplankton need to grow in addition to light. So there's a relationship there that's important to constrain. And then,
For viewers that don't understand, what are phytoplankton?
all right, so phytoplankton they're the organisms at the base of your food web. So they use photosynthesis to create themselves. So they convert inorganic nutrients, typically, and light into particulate organic matter. So they're the photosynthesizers. They're essentially the plants of the ocean, although they're not really plants.
Shifting gears a little bit, are you all concerned about the deep well injection that we're doing, that it could possibly reach into maybe underground watersheds and eventually get into water underground and leaking out into the bay?
I will let Tom handle that.
No, I think we need to appropriately kind of constrain the discussion here, right? The team that you see before us right now is really interested in what the consequences of the chemistry of the discharge water and how it affected the Tampa Bay ecosystem. So again, I think it'd be outside of our bailiwick really to be dealing with that one. Yeah.
Have you guys seen any fish kills? And if so, is it a way to tell that they've been the result of any red tide?
Yeah, I'm going to let Steve jump in here in just a second, but an immediate concern obviously was that you would have highly toxic water that was going to result in some type of a fish kill. We did not observe that, but the regular sampling that's been carried out in the bay wouldn't indicate that there's been any large mortality events either. I'll just make sure, I'll check with Steve. Yeah, Steve says we're all good there.
Let us know over the next coming months how important research will continue to be to make that baseline and continue to look at that.
Yeah, I think the question there is it important to go ahead and yeah, I think it's super important, obviously, right? And Zach made this point earlier. What we're trying to do is try to generate the data that will help better inform a more holistic sampling effort so that we can properly respond to these type of events, right? And so, yeah, we'll make every effort to continue the sampling well into the future.
So you're showing us these maps. Is this an encouraging group of data set, basically, that you're showing us with these groups of maps here? Is this something that the public should be encouraged to see?
Yeah, I think that they should take a good look at it, right? So essentially what it says that we've, as I go through the various images here, so we've got a suite of sampling stations. Some of those sampling stations were in the immediate vicinity of the waters that were subjected to the discharge, and that was informed by that modeling effort that Dr. Weisberg talked about. And it's important not only to sample in the water that's been affected, right, but to be able to sample in those outside areas for a comparative purpose. That gives us a better idea of if the model is performing well, whether or not that discharge water is actually being diluted, etc. The satellite imagery is also important, and we haven't heard from Dr. Hu, but I'm going to let him come in as well and speak to the importance of those issues. We've talked a lot about in-water sampling of water, sediments, and fish, but we've got a number of tools at our disposal, and we're fortunate to have a talented team of oceanographers here that can exploit those satellite tools to provide us information on the extent and the duration of that bloom. So I'm going to let Dr. Hu come and talk about those images in particular. I need to take a look at the image again. See what's on the screen. Okay.
So following the model and field measurements, we use satellite images to see whether there's a bloom and where is the bloom and what is the concentration and how long the bloom lasts. And the maps show the whole history of this bloom event. Dean Fraser just said that this is short-lived. How short? It's less than 10 days. Okay. How big is 25 kilometers square? And what is the concentration is between 10 and 40 microgram per cubic meter, or milligram per cubic meter. So is that big or not? Without historical information, we can't say anything without a reference. So thanks to Tampa Bay Estuary Program, they have been sampling Tampa Bay for 4 decades or 5 decades. So we have historical data, we have a baseline to tell whether this is significant or not. Okay. Is that significant in that particular place? Yes. It never happened in that part of Manatee neighborhood. Okay. Is that long enough? No. It's pretty short because most bloom could last for months. And also in Old Tampa Bay and Hillsborough Bay, there are way bigger blooms in history. Okay. So that tells us why historical information or baseline information is so important. And I think one question asked, what have we learned in history? What we have learned is that historical sampling effort is extremely important. And but they have a different focus. And some of the data, or most of the data, cannot be used to answer the questions about heavy metals because we don't have data. And thanks to this group effort, now we continue collecting those data. Hopefully we can answer questions that we were not able to in the past. And that's what those maps show.
I have one last red tide question, if you don't mind. If we have, and I know it's difficult to calculate, I'm not going to ask you to do that too much. If we had a bad bloom in 3 months, is this something where I think I've been here before interviewing about this 3 years ago? There's so many different factors that can contribute to red tide. How well would we even know whether or not this event? Can you speak to that a little bit and the complexity of determining the origin of it, I guess? Can someone talk to that?
You want to go? Yeah, real quick. So, yeah, I mean, it's a good question, right? And so I didn't get to the bottom 2 figures, and those are essentially the output from the models that Dr. Weisberg provided. But what we're trying to do with our physical oceanography group is to better understand the hydrography, right, and, of the region, so that we can better predict, right, where those red tide blooms, where they're initiated, where they're transported, and what mechanisms are responsible for moving them up and down the coast or inside of the bay. So again, I think from a scientific perspective, what we're able to do here at the College of Marine Science is to provide that basic modeling information, which relies, of course, on a number of in-field sampling measures to improve those models, so we're in a much better position to predict when those red tide events might occur and what might be responsible for their maintenance. So again, as Bob said, he's probably in a better position in a couple of weeks from now to tell you what might be happening there.
But it's the Gulf. It can be other factors, not just a spill. So
Yeah.
how do you even know?
Well, I mean, again, so what you want to be able to do is to have that background information, right, that tells you what the nutrient environment looks like in the bay. All, as Dr. Buck said, phytoplankton, red tide organisms, they respond to a couple important things, light and nutrients. And so whenever you put nutrients into the water, you're going to have the possibility of stimulating phytoplankton growth. And that's going to depend in large part on the organisms that are in the water at the time. And so, as I said at the beginning of this, until recently, we've had few to no red tide organisms in the bay. Right now, we're starting to see low to background concentrations in the southern part of the bay. But again, given the trajectory of the data that we see here, I don't think we're in a position to attribute any increase in red tide, right, to the discharge from Piney Point.
Let me ask you, were you worried when you were taking the test, were you worried about the impact on Piney Point in the environment of the bay, and how do you feel about the results?
So again, I think Dr. Murawski said it well. I think we're fairly fortunate that we didn't see a long-lived, widespread impact on this ecosystem. And I think, though, that the concerns that were expressed early on, particularly as they relate to the degradation of important seagrass habitats or on the health of seagrasses or other biota in the bay, we haven't seen any evidence, at least in the short term, right, of a degradation in seagrass habitat. But those data will continue to be generated by a number of other entities, and as Dr. Murawski pointed out, some of that processing with regard to potential contamination of fish tissues will take some time to resolve. But yeah.
The diatom bloom, just to focus on that real quick, it was fairly short-lived and fairly locally isolated. Do we know why that was the case? Is there anything to indicate why it didn't get worse?
Yeah, so again, that's I'm going to let some of the folks on the team talk to that, and I can let Kristen talk to it first, and then probably Bob next.
So I think one thing that's important to keep in mind about diatoms is that of the different types of phytoplankton, they also make a silica frustule on them. So they have a high silica requirement. And we did detect high amounts of silica in this discharge. So as these nutrients were drawn down, so was the silica. And at that point, the diatoms, when they get low in silica, aren't going to continue to persist. I think it's important to keep in mind these nutrients are going to be either consumed by phytoplankton, diluted. Bob just talked about the extensive dilution. And then the last thing we're kind of looking for is what may have ended up in the sediments, and that'll be a longer term question. Does that answer your question, Zach?
Yeah,
Okay.
But you want to
Nope. Yeah, Bob.
So the two pictures on the bottom help tell that tale. Initially, there was very high concentrations of whatever was coming out of Piney Point, and that's exactly where we saw the massive phytoplankton bloom. You can just see it by your own eyeball. And as time went on, it diluted down to much lower levels. So the dilution itself, combined with the consumption, would have accounted for why it went away. Somebody asked about the public. All of this stuff was available on the internet every day for the public to see. And there's a website, if you can ask me about it later. It'll also be in the blurb that you're given. But every day we provide a 3.5-day forecast of what the circulation in Tampa Bay is. And we're continuing to update this product to show how the dilution is continuing to occur. And so what we're doing in the college has applications well beyond the Piney Point effluent. If you go out in a boat and you'd like to know what the currents are, just go to the website and you'll get that. Thank you.
Go ahead.
What's next? What are you all looking to find in the next month?
Again, I think what we're going to continue to try to do is collect the same type of data that we've collected. Are we going to look at the chemical characteristics of the water in the immediate vicinity of the discharge point, as well as in other reference parts of the bay? We'll do that for not only chemistry, but some of the biological components, particularly the fish, and in collaboration with many of our partners, the phytoplankton and other microbiota. And The goal, obviously, is to try to better understand the complexity of that nutrient cycling that Dr. Buck was talking about. You know, we tend to just focus on nitrogen and P without too much regard, whether it's ammonium, whether it's nitrate, or some other form. But all of these conditions and assimilation and other processes will affect what's available to various organisms, and has a tremendous consequence for which organisms might be in the best position to exploit those nutrients if they're in abundant supply. Yep. All good? Thanks everybody for your time. I really appreciate it. Thanks, guys.
Good job.
Good to see you guys. Yeah, right?